fan. It's cold, but I have a fan here. I put on a different jacket. I put a different jacket on because it was so cold that the other jacket was just not strong enough, warm enough. And this is a pretty good jacket that I got, eons ago in at Costco. That's where I got it, at Costco. So eons ago, I got this nice jacket, and I got this really cool fan here from a hotel in New York. So that's another thing there. Anyway, traveling. It's not something that I like to do anymore. I'm so tired of traveling. So I only travel when the boss says go, and you have to go. Else I'm fine staycationing, hanging out in the 3D space. In the Matrix. Anyway, guys, I'm here with all the usual stuff. For all the girls and boys of all ages. No, it's okay if you're 103 and more. You're not excluded. You can still watch. It's okay. Everybody can watch. Here's a funny story about the cube. So I promised you guys, and look, I delivered on my promise. What if the politicians could do that? I said that next time you'd see me, I would have the famous 9 squares on the bottom. I think that's accurate. 9 squares at the bottom, and then the 6 squares going all the way aroundly here. Sometimes with the light, it'll glitter. The sheen is so strong that it'll just overpower the camera. But you can see that there's 6 on here. As I said, there were going to be 6 on there, 6 on there, 6 on there, all the way around the cube, and the famous 9. So I did that. The unfortunate event, right? The series of unfortunate events. So the unfortunate event here is that as I was doing that, I went through more steps than I was supposed to. So usually once you're done with the bottom there, what you do is you turn the cube this way, so you are less likely to mess up the bits and bobs underneath. So at each point of the cube stage, there's different ways of holding the cube. I mentioned a few of these in the previous live streams, but at the very end, when you get to this point, to make it easier for the dummies such as myself, what we do is we turn the cube this way, and all of basically the done stuff is on the bottom, and the last level of the cube here is what stays on the top. Unfortunately, as I said before, what I did was I did all this thing, and I went through, because usually there's a bunch of steps that I go through, right? I go from 1 all the way down there, and then at that point I already found myself here. These are the final steps here. So where do we get to? Was it 6? So then you would have 7, and then 8, 9, and then 10. So accidentally, because I'm always getting distracted by the squirrels, as I went through it, I went to the next level. And so now if you can see up here, it's not just really 6, it's that we've got the middle cubes already completed there. You see that? All the middle cubes in each of the sides are complete. So technically we have 6 plus 1 is 7. I think I can still do that math. It's hard for me, but I try my best. So now all that means is that most of the other bits and pieces have been completed. There's an important step in here, which is at one point before you get all these middle cubes to match all the way around, is you'll have 2 of these cubes. If you keep sliding around and doing the thing, the doobly-doo, which is to bring one of these up here, that twist it around and then twist it back so that it comes back in there. Eventually, when you do that strange algorithm there, eventually what you'll get is at least 1 of these to match and the other one to match here. So long as you have 2 of those, what you do is you turn the cube with if you have at least 2 of these that are matching, you'll do the exactly thing that you see here. One of them will be pointing away from you, and one of them will be pointing to your right side. Then you'll run that algorithm. There's one of the algorithms that goes through the thing. Let's see, what's the algorithm there? I believe it is right up, top left, right down, top left, right up, top left twice, and then right down. And then that one will then lead you to where we are here right now, where there's bits and bobby here, and all those are done. Now the next one that you need to do at this point when you get here is you need to find one of these last, because there's only 4 bits that are really mismatched at this point, and they are the 4 corners of the cube. You need to find the one that's mismatched, as in it's in the wrong direction, but what it does have that is correct is the same colors. So in this case, it is this cube right here. If you see this cube right here, it is not pointing correctly, but if you see, it's got yellow like the middle one here, it's got green like the middle one here, and it's got red like the middle one here. So what you do is you get this one and you face it towards yourself, and you run the last algorithm, I do believe, which is really complicated because the first part is easy, but then you forget what's going on. So there's a chance that I could still get this wrong, and it is a very, very high chance. So what you want to do is to do a right up, once that cube is in the correct area, and again, I have to have it facing me. So just so you guys know, this will be facing you, and because of the camera doobly-doo, when you see it, it doesn't look like that. So make sure that this corner here that has the colors that are aligned the way that I just explained faces you. And then what you do is right down, bottom left, right up, bottom right. And then there's a part where you need to actually do a rotation of the top there in order to get it right. And that's the part that I always forget. So there's a good chance that I'm going to screw it up. And if I do, then I'm going to have to do all of this again and try this again tomorrow. So because otherwise it's going to take me like half a day just to do this. And I want to get back to doing all the cool stuff with Ome Wing Chun, Yin Kai San, Sam Nung, and Grandmaster Tom Wong, as well as the lab tech stuff that we do every morning. So anyway, usually I do this at the end, but this is what happened now. So let's see if we can finish it off. I've done it many different times with this cube, but also the Disney cube. But again, that was offline. So, I mean, there's a big difference there. There's a big difference in doing it live streamed and when you do it and it's not live stream, it's just easier. It's just easier. So right up, bottom left. So right up, bottom left, right. Wait, I just got that wrong already. Right down, bottom left. Right down, bottom left, and then up and down like that. Now the problem is I've done that now, and theoretically, if I keep doing that, it should fix it. But then there's that doobly-doo that I explained before, when you really need to. And I think the problem is, and I always get stuck here, is I can't remember at which point you're supposed to do the other rotation. So I think I've overdone it now. I've overdone it and I've ruined the cube tutorial. Did I? I think so. I think I've completely ruined the cube. I've ruined the cube tutorial. So it does work if you know how to do it properly, which I've just proven I can't do it. It's down, and then it goes backwards up there. It's not even going back to its original spot, so I must have done something. I must have done something that totally wrecked it. And I know it's that final step. Oh no, okay, we're back to normal. So if you keep doing the same algorithm over and over, it'll take you back to normal. But as you can see here, it hasn't fixed that, and it should have fixed that. The reason why it didn't fix that is, as I said before, because there's a point where you do this, where you do need to adjust the top thing in order for it to work. And I didn't do that. And I can't remember at which point you're supposed to do that. But it does say in the instructions that I made for myself, and I got those instructions from another YouTuber. So it must be right. It must be right, because I saw him do it over and over and it worked. And it did work for me in the past. I just can't remember at which point you're supposed to do it. I know it's down, left, and up, and like that. But then I don't remember at which point I'm supposed to knock it back to a different direction. Maybe it's it's at this point. I don't know. So up. No. How do I undo what I just did? I don't know how to undo what I just did. It would take forever. It would take forever. Darn it. Darn it. Maybe I'll just do this. Maybe I'll just do that. That. Oh. It's not working. It's not working. It has worked in the past a lot, but it's not working for me today. I'm going to have to go study his video again. He's the real genius. No, that's probably not right. It looks better, but it's not right. And it's not coming back to normal. I must have done at least 200 or 300 things wrong. Endless stupidity. Endless stupidity, guys. Endless stupidity. I can't even blame the squirrels this time. I just did it wrong. So anyway, I guess what we'll do is I will go home and cry to myself for screwing up the whole thing. And the next time that you guys see me, I will have it back to where we were, or similarly to where we were today at the beginning of the live stream. And then we will do it again. Trust me, I'm not going to do the Disney work. The Disney one is just so much more hard. It is just so much harder than this one. So we're not going to do that one at all. But this one turned out great. In Backwards World, this one turned out great. Anyway, let's jump into the things that we do here with technology, because that's what you guys were here for anyway. I'm sure that you guys were here for the technology stuff. Oh, it's great. The greatest thing that happened this week is that I have received the coolest Terminator robot, and at least yesterday she did not glitch out at all. She was just beautiful and so well behaved, and we almost got her to say that the 3D printed elephant is pink. We almost got there, and the reason why we didn't is because too many words were being flung at her, and I probably overpowered the software engineering system in there. I was talking about like 1,000,000 miles an hour spouting words, and so I need to slow it down. So I will train her off live stream so that she can say the things that she's supposed to be able to say, and then we'll have her answer some of the questions that I have pre-programmed in her, and that'll be pretty fun. But she said that the elephant was blue, or could have been gray. She never said pink. But again, I said that was my fault. Excuse me. Early morning burps. Ugh. It's nice to have the sun. I've got more power. The sun powers the lizard people. So, all right. Now that we got that out of the way, let's do some reading. We said yesterday we did a bunch of things. We created our own battery And the battery was designed to turn on some fairy lights, and that was cool. I enjoyed that. So now today we're going to talk about motors. We're here with the motors. Let's get on with it. Electric motors convert electrical energy into kinetic movement energy. In this project, I always think bind because you're usually binding things with remotes. No, you will build. So in this project, you'll build a simple motor using electric current supplied by a battery. The current flows through a coil producing a magnetic field that interacts with the magnetic field of a permanent magnet. The magnetic forces between the coil and the magnets make the coil spin at a high speed. All right, so how does this work? There is a coil. You send a voltage through the coil. The coil will then spin and do funny things. So let me just show you what the picture is all about in a second. I'm just going to read some bits from the picture diagram here. The permanent magnet's invisible magnet field interacts with the magnetic field around the coil, causing the coil to spin. The coil spins rapidly whenever current flows. When current flows, the coil produces a magnetic field. So here, I'm going to show you this thing. The battery supplies direct electric current that flows through the coil. Let me show you all of that. So that was the motor bit. And then on top, you'll find that there is this motor system. And as you can see there, whoa. As you can see there is a coil of copper wire there held by some clips. The clips are mounted onto this piece of, I guess, wood that is porous, that you can stick things through like that. And then porous meaning it's got pores. It's you can stick things through it quite easily. It has like little holes, pores, just like your skin. Anyway, here you've got a massive battery there and a magnet on top of it. That is just the right distance between the coil there to give it that once that electricity passes through there onto these bits, somehow allows it to spin like a tabletop, but in a different direction. So how to make a motor? So this is just a very basic motor. It's not a good motor. It's not going to be able to do much for you other than be a nice, fun experiment. Because if you don't do it correctly, you won't have, it just won't be very accurate. It won't be a good motor that will be able to power your RC cars or anything like that. So the part of your motor that turns the rotor is a coil made of copper wire. The wire has a coating that prevents electricity from passing through the circuit. So it is important to scrape the ends of the wire so an electric connection can be made. One thing that I forgot to mention, you guys, from yesterday's episode was that a good way to clean the coins if they're very rusted sometimes is to use Coca-Cola. Coca-Cola will get a lot of the stuff off. You want to make sure you rinse it off very well if you wanted to use that other special solution, because I'm not sure that Coca-Cola would do very well in a battery. But, you know, thought I'd just mention that if you've got some rusty copper that you're working with, sometimes Coca-Cola will help get the rust off if it's very rusted. But you could also use some metal tools to scrape the changed or the messed up oxidized bits. All right, so wind. Did we get back to the thing? Wind the enameled copper wire around the battery 5 times. Leave about 2 in 5 centimeter of wire on each end. The 2 ends should stick out from each side of the coil. All right, I'm going to show you what that looks like in a second. Here it is. And that's what it's supposed to look like right there. But anyway, take the wire off the battery, flatten it into a circle, Then wrap the two ends around the coil at the opposite sides of the circle to hold the coil together. So then it says, by using the utility knife, scrape off the enamel coating on the free ends of the wire right up to the coil so that the shiny copper is exposed. I'll show you guys this thing right here. So just in case you guys are preparing yourselves to do this project yourselves, this is supposed to be a 15 minutes exercise. Yeah. If you've ever taught in the classroom with a bunch of amazing kids, even if they're super focused, a 15-minute task tends to drag on to at least twice the time. Simply because, you need to explain the project, how it works, and then get it done. And even if you demo it all by yourself at the beginning of class to the students and then say, go off and do it yourselves, yeah, it's going to take more than 15 minutes. 15 minutes is if you've already done the thing yourself, right? You're very confident in what you know how to do, and you got it all down, then it will take 15 minutes. So don't always go by the times that they give you in books, because let's face it, they're either for geniuses like, Einstein's, or, if it's in a classroom setting, it's going to take longer. What you need from the toolbox is a utility knife, wire cutters, and a ruler. And you know how crazy Russian dad loves his rulers? Well, you're going to need one for this one. So if you haven't seen that video about rulers and Russian dad, crazy Russian dad, go and check that out. It's a pretty fun video. Anyway, so I'm going to show you the pictures here of the tools that you're going to need. As we just explained, the main tools that you're going to need are going to be utility knife, wire cutters, and a ruler, but then you're also going to need a magnet. It's rather a large magnet because the battery that it goes on to is a 1.5 volt D battery, and they tend to be pretty large. Not very common anymore. However, they are in this book. So safety pins, you're going to need safety pins. You need enameled copper wire, a 28 gauge 25.5 in 65 centimeters, whatever that means. Just go to Home Depot with this book and ask a happy and amazing customer service representative, and they're always super helpy. God. Words. Super helpful. Also Home Depot as well. I don't go there much often because usually the plaza where I go tends to have Lowe's, but Home Depot is also very good for that, and they will be able to help you with all that stuff. It also requires this thing. This is a cork tile, but anything that the pins can be stuck into can be used for the base. So the base is going to be a cork tile. See, I didn't know what that was called. You also need possibly 2 rubber bands. So anyway, here is the picture of the tools that you're going to need right there. And I hope that you guys can see everything, because it's hard for me to see if I'm showing you all the stuff. Great stuff. Let's move on to the next bit that is required. So in the next step, what you're going to need is the pins. So bend open both safety pins so that the arms on each form a 90-degree angle. Be careful with the sharp points, of course. Whenever you're dealing with a utility knife or pins, sharp objects in general, be careful with the point. It is easy to get that point to stick into something that you don't want it to. It says the loop that joins the 2 arms will support the coil. Wrap the rubber band around the battery. It needs to be tight, so double it up if necessary to increase the tension. So what's the point of the rubber band? The rubber band is going to hold the paper or safety pins in place so that they touch the ends, one positive, one negative. And then those things are going to push into what was that thing called again? Something corky. The cork tile. Here, I'll show you real quick in the pictures. These are the safety pins. That is the battery, and the rubber bands go around there. And then, as you can see here, this is the cork tile, which is the bass. Because they're all about the bass, no treble. And then you stick those pins in there so that they hopefully stay in place, and the battery stays in place there too. You won't want to wiggle the bass because otherwise things will fall out of positioning. So if you've got a glue gun, and you've got a bunch of amazing kids at school, you could glue gun the battery onto the cork tile to stop that from moving. Just saying. I mean, it's a little thing that might just make the whole exercise a little bit easier. It doesn't say that you need to do it in this exercise, but knowing me, there's a good chance that the battery will get knocked out of position. Push the clasps of the safety pins underneath the rubber band, one at each end of the battery, so that they are held firmly against the battery's terminals. That's what I was talking about, except I didn't know what the terminals are. The ends of the battery, one positive, one negative, in layman's terms. Place the construction onto the base, push the sharp points into the cork, make sure the loops are at the same height. So you want to make sure those two loops are the same heights, because now the next step of doom is to grab the copper wire thingamajig that you created and to push those things through there. So let's see if that's correct. Gently feed the ends of the copper wire through the loops in the safety pins so that the coil is suspended. Straighten the pins again afterwards. Place the magnet on top of the battery. It will stay there without any glue because the battery case is made of steel, just like Superman. A magnetic material. All right, so let me show you the pictures on this. Here we go. Pictures on this. Here's one picture. And there's the other picture over here. As you can see, that copper weird circle-ish thing that has two legs, one on each end, slides into the pin section over there, and that's what it looks like in the end. So there you go. Now give the coil a spin. If the motor is working, the coil should continue spinning on its own. Okay, that's interesting. So okay. That's all you have to do then, I guess. You just spin it once, and then through the power of electricity and inertia, I guess it will keep going. It says, beware, don't leave the motor running for long periods, as it can get quite hot. Take the coil out to stop the motor. So yeah, be careful. Whenever you're dealing with electricity and technology, things can get rather hot. So I don't know if that coil will ever get too hot. Don't leave it running for a long time. If it gets hot, you might need gloves to stop this thing from running. I can see lots of different ways this could be a disaster, but don't listen to me. This is made for kids, so hopefully it won't be. Having taught in schools with amazing kids, things can go wild, but most of the time, let me just say this, most of the time the instructor is going to make the mistakes, which tends to be hilarious, so most of the time the kids are safe. It's just the instructor will do stuff. You may need to experiment with where to place the magnet in relation to the coil to make the coil spin faster. The battery provides the motor's electric current. The coil may get hot if left running. How it works. Electricity and magnetism are closely linked. And when electricity flows through the coil, it creates a magnetic field around it. Pretty cool stuff. This is also true with, and why a lot of people think that Tai Chi and Chi is mumbo jumbo, but it has a lot to do with blood flow, has a lot to do with electricity, and it has a lot to do with magnetism. all of those things work together around and within your body in order for chi to work. So although it sounds like mumbo jumbo, it's true. It's true. Anyway. The permanent magnet and magnetized coil each have a north and a south pole. Like poles, north and north or south and south repel while opposite poles attract. When you spin the coil, its south magnetic pole is attracted to the north pole of the magnet. The spins, what? I'm not sure if that's correct, but anyway. It says the spin's momentum takes the coil's south magnetic pole beyond the north magnetic pole of the magnet. I think there may be some Englishing that needs to be corrected here. Anyway, so north is the red pole and the south pole is the blue pole. And then it says the same thing about the coil. I'm going to show you the picture about all this so that you guys can see what I'm talking about. And then it says the north pole of the coil is then repelled by the north magnetic pole of the magnet. This process increases the momentum, which keeps the motor running. The coil spin is affected by the coil size the material is made of and the amount of current flowing through it. All right, I'm going to show you the picture of this, but before I do, I'm just going to show you, just read one last bit, which says, real world inventions robot arm. Motors are used in many tools and machines, including cordless drills, small toys, and even robot arms. The fine precision needed by a robot is achieved by motors located in each joint of the arm. Again, as I said before, this motor that you guys can create is not precise enough to run motors such as the ones in the picture over here. So this just shows you how the thing works and the polarity of the magnets and stuff like that. But nothing like this is going to be able to run motors like you see in a lot of the projects that I've put on the channel, such as Alpha the Robot, and a bunch of the other robots that I built, Plan 2 and stuff. These little motors that you just built with me will not be able to power that because they're just not accurate enough. All right, so let's jump into something called a generator. We're going to build a generator here with CDs. Do people still use CDs? That's going to be an interesting question for the internet. Do you still use CDs? Put it in the comments. All right, generator. Most of the electricity supplied to homes is produced by machines called generators, which convert kinetic movement energy into electric energy. A generator contains coils of wire arranged around a spinning shaft. Oh, excuse me. Excuse me. Oh. I guess a particle of dust must have gotten into my nose, and I am allergic to dust, and so there we go. A generator contains coils of wire arranged around a spinning shaft surrounded by magnets, just like a motor. In fact, you can use a motor to generate electricity, and that's just what you'll be doing in this activity. All right, so we're going to create a generator by using motors and something else, which we will describe in a minute. So I'm going to read some of the bits and pieces so you guys can read or actually see the picture that I'm going to provide to you. Turning the crank handle provides kinetic energy to the motor. The large wheel acts as a pulley, turning a rubber band that is attached to the motor. The rubber band turns the motor shaft, which produces electrical energy, and a current flows. The LED lights up when a current flows. Okay, so we're going to show you guys what this is all about. Take a quick look at this cool invention that they made. It is a generator. There you go, generator. Hopefully you guys can see the generator with all its amazing components. It's got some stuff that you get if you buy ice cream, like the wooden sticks from the ice cream and stuff. It looks pretty fancy-pantsy and fun. So let's see how to make a generator. It tells you that this is going to be a task that was going to require 45 minutes. Usually in a classroom, you want to probably double that, but maybe it won't. Maybe it won't. Maybe in some of these may require more time depending on whether you have the tools ready or not. And I guess before you start bringing the kiddies into your classroom, you probably want to have all your tools ready and set up and ready to go. You might want to have practiced the exercise at home a few thousand times before you humiliate yourself in front of the class. Oh, the things you learn. How to make a generator. Here we go. So make sure you follow the instructions carefully, as this build relies on the supporting frame being sturdy. Try to find a medium-sized rubber band. If it is too big or too small, it will not drive the motor shaft around effectively. It's okay if you can't find any old CDs. Try to find something sturdy with the same dimensions. It says 4 3/4 in, or 12 centimeters in diameter. Fun stuff. Anyway, so CDs. Again, that's a good question for you guys. Does anybody still use CDs? I'm gonna go through. This is a medium difficulty level for this thing. It says, beware, it requires a hot glue gun, hacksaw, drill, utility knife, and wire cutter use. So all this stuff could be dangerous if, excuse me, if kids use it. So make sure that a teacher is at present, or if it is an adult that can't be trusted with tools, make sure that someone who is a professional is around. Anyway, so let's go through the things that you will need for sure. What you need from the toolbox: a utility knife, a cutting mat, hot glue gun, adhesive putty, ruler, scrap wood and clamps, hacksaw, drill, a 1/8 or 1/8 in 3mm drill bit for wood, wire cutters. You'll also need a corrugated cardboard. I guess, I'm not sure why it's corrugated, but it's corrugated. It's basic cardboard. It's a little bit thicker, maybe a little bit rougher than most. Anyway, you will need a green LED, but I guess a red LED will be fine too. In the original picture, I think it used, oh no, I was wrong. It's also a green LED, but it was lit, and I guess it was blown off by the picture when they took the shot, and so it looks different. I thought it was just either white, but anyway, it doesn't really matter. It says a green LED, get a green LED. If you've got a different LED, I'm sure it will work just fine, but per the requirements here, it says green. Rubber band, also green. Maybe it was Christmas themed because the wires are red. It needs 2 wires with crocodile clips at each end, and those are red. So you're gonna need a resistor with 150K ohm resistor. Anyway, you're gonna need a 6 to 9 volt motor, and you're gonna need 2 compact discs. You will need 2 wooden skewers, 1 wooden base, at least 5 times 12 in, or 12 times 30 centimeters. And you will need a tape roll. You will need a glue gun stick from a hot glue gun, and that means you will need a glue gun that goes with it, which is not said here, but it says on top earlier. 9 craft sticks, which are usually, you can also get from eating too much ice cream. So you can either buy those or you can buy the ice cream. Enjoy the ice cream first, and then keep them, clean them, and spare them for your projects, which you probably should do anyway, because it's a good way to recycle stuff for your projects. Anyway, so on page 22, it tells you how to use a glue gun according to the Eye for Information thing. So cut out 2 cardboard discs with diameters smaller than the inside diameter of the tape roll. Using the hot glue gun, stick the discs over the holes in the centers of the CDs. You probably want these two cardboard discs to be the same size roughly. So once you make one, make sure that it's very nice and rounded, and you could use that one to make the next one. So like if you have a large class, large group of kiddos, if the teacher makes one, maybe he could make two, or she could make two, or whatever, and then pass that around so that the kiddos can use that to trace to make as many are as required by the exercise. It's good to have all that stuff down and written down on a nice sheet of paper so that when you're doing the class, you don't have to guesstimate how many things need to be done. And that's my OCD talking. That's my OCD talk. Oh, the amount of work that I used to do. Anyway, cut out 2 cardboard discs in diameter smaller than the inside diameter of the tape, as I said before, and blah, blah, blah. We'll get all that done. And then it says to make a hole at the center of each CD. Okay? It probably means disc, not the CD. The CD should come pre-holed, if you will. Otherwise, when you try to put it on a CD-ROM player, it's not going to fit. So I don't know what the thing was smoking here. Anyway, use a wooden skewer to poke a hole through the center of each cardboard disc. A lump of adhesive putty will help you make a clean hole. So if you put the adhesive putty behind the disc, when you try drilling the hole, it'll be better. Anywho, run glue around the edges of the empty tape roll. Press the roll onto one of the CDs over the cardboard disc, making sure it is centered. Next, press the other CD onto the tape roll with the cardboard disc facing inward. Facing inward. I'm going to show you 3 images here. All right, so this is image number 1, where you create the disc and put the glue around the disc so that then you can glue the onto there. And then going up further and further until you get to the last bit over there, number 3, step 3, that we just went over there. Okay. Wonderful. Once the glue has dried, push the skewer through the centers of the cardboard discs to form the shaft. Make sure there is an equal length of skewer on each side, then glue the shaft to the cardboard on each side. Great. Great stuff. It says to then glue together 2 of the straight cut craft sticks. Then repeat with other 2. These are the legs that will support the generator's pulley wheel. So we're going to need to make those. But I guess I just missed a step because you can't do that step unless you've cut. You need the hacksaw. You need a hacksaw. It says to cut 3 3/8 inch, which is 1 centimeter. So I don't know why the American system really confuses the live heavily. Oh gosh, okay, having a moment here. The American system confuses the living heck out of me because it's got all these fractions all the time. It forces you to use all these fractions. You go with the centimeter, it's just 1 centimeter. Makes it easier. Less math to deal with. Anyway. So anyway, you need to cut off a certain amount of the thingy-majig at a certain angle in order for this to work. So it says cut off the 1 centimeter off one end of 4 craft sticks. Next, cut one end of the 4 more craft sticks at a 45 angle, as it says here, starting with the 3/4 thing in 2 centimeters up on one side. Whatever that means. That's where the math gets all complicated. It doesn't look complicated in the picture. So just take a quick look at the picture and you won't feel like it's really daunting or anything. You go take a look at those other pictures too while we're there. Great stuff. So using a drill bit slightly wider than the wooden skewer, drill a hole through the middle of each of the legs, about, again, 3/8 in 1 centimeter for from the rounded end, So the rounded end, the one that you did not use the hacksaw to cut a bit off, that's the bit that you want. That's the bit you want. All right. Just got distracted by some pretty ladies with a dog. What am I going to do? Anyway, let's get back to it. Using a utility knife, cut 2 discs, each about 1/4 in 6 millimeters thick, from an unused glue gun. All right, cool. Good stuff. It talks about using use a cutting mat to protect your work surface. Hold the glue firmly so it doesn't roll as you are cutting it. So the discs will help keep the generator's shaft in place. Oh, great. Oh, great. We're getting it step 9. And step 9 is quite fascinating because now you got to have a bunch of CDs stuck together with a cool thing and a shaft going through it. Oh, great stuff. Anyway, so 9. Stretch the rubber band around the tape roll. This will be the belt of the pulley system that attaches to the motor and turns the generator. This is pretty cool because some like RC drift cars also have a belt system with a pulley that helps your cars drift even better. So then we are at part 10 of this bits and using pointed end of a skewer. So we're going to be using the pointed end of a skewer, make a hole in the center of each glue stick disc. Push one of these discs onto side of the shaft of the pulley wheel. Set aside the second glue disc. So once all of that is done, we're ready to get the ruler. And we're going to have to do some calculations here. So on the wooden base, make a mark about, again, 3/4 in inches. 3/4 is 3/4 of an inch, which equals to 2 centimeters. So, just for easiness purposes, if you've got one of the rulers with double sides, 1 in inches and 1 in centimeters, go with the centimeters. It's just so much easier to work with. In from each side about 5 inches or 12 centimeters. Okay, from one end. Glue one of the legs on top of one of the marks and wait for the glue to dry. The second, I'm going to show you all these images so you guys won't get too confused. And then it says push one end of the shaft through the hole in the leg already in place and feed the other end through the hole in the other leg. Glue the second leg on top of the second mark. All right, we're almost there. We're almost there, guys. It's getting exciting. Are you passionate about it? Oh, God. Are you passionate about this bit? I don't know. Use the angle cut craft sticks to make support for the legs. So we're going to make supports for the legs. Glue the rounded ends to the legs. One on each side of the leg and the flat angled ends to the base. Use the wire cutters to carefully trim the ends of the pulleys shaft on both sides, leaving about 1.5 inches or 4 centimeters. Again, 4 centimeters, really simple to remember. 1.5 inches, not so much. On each side of the legs. Here we go. I'm going to show you guys all of the images that we've just done, just in case you are creating your thing yourself. If you're trying to create the thing yourself, here are the images to go with that. How cool is that, guys? You're about, let me see. You're about halfway through the project. Boy, is that great. Is that great? Are you excited? Do you feel the passion? Do you feel the passion? I don't know. Oh, anyway, so 15. Using the last craft stick, cut a length of about 2.5 inches, which is equal to 6 centimeters, which is going to be easier to remember. I don't know. From it for the generator's crank handle. Drill a hole about 3/8 inches, which is 1 centimeter, in front of each end. Okay, let's do that. Cut a piece of wooden skewer about 1 inch, which in this case is going to be 2.5 centimeters. So now it went the other way. Now it's easier to do 1 inch long and glue it into the hole at the rounded end of the handle. So if in doubt and you've got halves in there and you have to do fractions, just use the other measurement. Oh boy. Push the second glue disc, C step 8, onto the end of the pulley shaft at the same end as the first glue disc. All right, so the first glue disc, great. This is looking pretty cool already. It says, check that the shaft can turn freely. If it doesn't, then you know you've got a big mistake, and you're gonna have to do this again, because otherwise the whole thing is not gonna run, and you may burn the motor when it starts pulling on something that doesn't turn. The glue discs keep the pulley in place. It says to push the crank handle onto the end, the other end of the pulley shaft, making sure that the wooden skewer on the other end is facing outward. Secure it with hot glue. So word of the day is outward. Okay, let me show you all the pictures. So in this picture here, you're drilling a hole, I guess, in the bitty boo. In this one here, you are attaching hot glue, and below you have the pulley system. Oh gosh. Okay, hopefully you guys can see it better than I can. The sun and stuff is shining directly in my eye. Okay. We're almost done, and then we can jump into the world of Wing Chun, if you will. All right. Find a place for the motor in the center of the base, far enough from the pulley that the rubber band is taut. All right. Glue the motor down, then stretch the rubber band over the motor shaft. Okay. Make sure that the center of the pulley is in line with the motor shaft. Okay. It says then to cut another 1/4 inch or 6 millimeter thick disc from the glue gun stick. Okay, so you're basically using the glue gun stick itself. You're just cutting a piece out of that instead of creating something else to go in there. That's going to be interesting, because if you don't get it exactly in the center, you're going to have a very wobbly bit in the middle there. Okay, that's interesting. Anywho, I guess what matters is that the rubber band goes on top of the shaft of the motor, and so that one is going to be perfectly normal. So what you're just using the glue bit to keep that from slipping out. So anyway, so it says push the glue stick disc onto the shaft of the motor. Okay, cool. Carefully bend the legs of the LED up. Next, glue it to the base with a blob of glue. All right, so but you need the legs to poke through the glue so that you can attach things to them. So you're bending the legs of the LED, you're gluing the LED onto that cork thingy-majig that's the base, and you're making sure that those bits are poking out so that you can attach things to them. It then says to attach one end of the 150K ohms resistor to one of the terminals of the motor. It says it doesn't matter which one. You just got to do it on one of those. Then it says, using the crocodile wires, connect the clip of one of the wires to the free end of the resistor, and the clip of the other wire to the other terminal of the motor. Connect the other ends of the 2 wires to the legs of the LED. The generator is ready to operate now. All right, I'm going to show you all of the pictures in this cool bit so that you guys can see all of the steps. That's one picture there, one there, and another picture there, and another picture there. Hopefully I am displaying them in roughly the order that you need to do them. It's hard to do because I can't really see what I'm doing. And so there we have most of that done. So then in part 25, it tells you to turn the handle of the generator and make sure the shaft of the motor is turning. Okay. LEDs only light up when the current flows in one direction. So if it doesn't light up, it may mean that the current is flowing the wrong way. So make sure that the current is flowing the correct way, because if not, it's not going to work. Try turning the handle the other way or switching the crocodile clips attached to the LED, as this will switch the direction of current from the motor. Sounds pretty straightforward. Turning the handle spins the pulley. This spin is transferred to the motor via the rubber band. As the motor spins, it creates an electric current in the circuit and the LED lights up. All right, so now it's going to tell you how it works, but before we do, I'm going to show you what it looks like. This here is your finished product right there. Okay, glad that was riveting, exciting, flabbergasting, if you will. And this is why we have, let me check the numbers there. 3 million subscribers are watching at the current time. That is amazing. Oh God. Anyway, so this is how you kill your YouTube channel. In the words of Eli, the computer guy, this is how you kill your YouTube channel. But that's okay, because that's the kind of stuff that I like to talk about and read about. But it kills the YouTube channel. So my advice to you, my 5 cents on this, my 10 cents or whatever, my 5 or 10 cents on this is, if you're going to make a YouTube channel, don't make it about technology. Oh gosh. Anyway, so how it works. A motor is designed so that its shaft spins when electric current flows through it. However, this process can be reversed. Spinning the motor shaft can be used to produce an electric current. Inside the motor are static magnets, as well as 3 coils of wire that can spin. Very cool. So real-world inventions, hydroelectric power. Nearly 1/5 of the world's electricity is generated by hydroelectric, the energy of moving water. The machines in this picture are turbines at the Hoover Dam in Nevada. It's pretty close to here. Pretty close, Nevada. The turbines spin as water pushes through them, turning generators that supply electricity. Very cool stuff. Very cool stuff indeed. How it works. We talked about that earlier, so we're going to talk about 2 magnets with north red and south blue poles sit inside the motor casing. I've opened up a decent amount of motors, and all the motors that I opened up did not have blue and red magnets, so that's something that works great here in the pictures to learn stuff. But in real life, the majority of time, I don't think I've ever seen any blue and red inside the magnets. It would probably be cooler if they painted it that way, but I'm not sure if that would decrease the effectiveness of the magnets, so I'm pretty sure that they don't do that to the magnets. But yeah, for safety purposes and all that stuff, if you were to do projects like these in class, doing some level of color coding will make it a lot easier. Also for the demonstration, it'll help kids understand what is what. The magnetic fields exert force on the electrons in the coils of wire. There is a motor casting on the exterior of the motor, into which you can then insert the motor itself that will then be able to spin with the magnets on the exterior bits, and the coils are usually wound around a shaft bit with some metal bits as well around there, which are kind of cool to look at. You'll be able to see it in the picture. Don't worry. I won't leave you behind, as they often do in real life. As you turn the crank handle, the pulley transfers this force to the motor shaft. As the shaft turns, the coils spin rapidly through the magnetic fields. Inside the spinning coil wires, the magnets cause electrons to align and push through the wires, producing an electric current. See page 30 for more on this. So you have to go all the way back to page 30 to take a look at that. There's an image there that shows electrons that are green moving through the copper atoms orange of the wire. The commutator is a component that transfers electric current from each of the 3 coils of wire to the motor's terminals. The electric current passes into the motor's terminals, supplying power to the LED. Awesome. And that was all, folks. So I'm going to show you the picture because I don't want to leave you guys hanging. This is the picture that I just mentioned over here. Above, you will find the hydroelectric power plant system. And that's all, folks, for today. Today, we concluded 2 fun little experiments. I think it was 2 fun. Who knows? I think it was 2 fun. If you can't remember if it was 2 or not, just go back to the beginning of the video and watch it again. Oh, God. Anyway, so tomorrow we are going to be building a handheld fan. And you know how much I love my fans. Anyway, so that was that for technology today. And lo and behold, there's nobody watching. Lo and behold, there is nobody watching. There were people watching for the Rubik's Cube. Anybody watching technology today? No. That's okay. 9 billion eyeballs out there if you count the people that are not, people without passports and IDs and stuff. Plenty of people out there that are not mentioned in the Google settings because you can only count the people that you know truly exist. The people who don't exist because they don't have passports or legal documents and stuff like that, they're not mentioned, which is why there's probably about 9 billion human beings, well, human beings, if you add galactics and all that stuff that nobody wants to disclose exist, there's about 9 billion of us on planet Earth. If you want to count people in different dimensions that exist on the same plane of existence, then that's a whole new argument that we won't get into today. But anyway, can't believe it. 9 billion eyeballs and 0. It must be a joke. It must be a joke because every time I use other apps, when I use other apps like Likey, TikTok, and a bunch of others that I don't want to mention because if I mention them, then the big syphilitic people in the social media world will go and destroy them, which has happened before with some of my favorite apps, Zyn and Dubsmash. Now, Dubsmash was supposed to be acquired by Reddit and become part of Reddit, but I still haven't figured out how that works. So anyway, if you know how that works, please put it in the comments. Teach me something. I spend so much time teaching you guys things. Maybe teach me something. Oh, the network has forced off. Oh, that's the best part. The best part of this week, guys, is that Tiny Doll came in. We have a new robot head from the Terminator. She's beautiful. She's amazing. And so far, the network has not forced off. So let's keep our fingers crossed that it doesn't happen because it's fun. It's fun. She's fun. She's quite the character. Anyway, Emma. All right, let's get into here. Ome Wing Chun. If you guys don't know about this book, you guys can get it off of Amazon. It is amazing. It is great. And most importantly, it is put together by a group of amazing people. Grandmaster Tom Wong created it, and then a bunch of his amazing students helped him put it together, publish it, and all that good stuff. So now it is on Amazon. Get yourself a copy, if you will. Anyway, so there we go. We're going to jump into some of the history of Wing Chun and some of the stuff that you need to do. I may have to go back a little bit because the Wizard of Oz, how far did we go yesterday? I don't know. I'm a little bit Excuse me. All right, so we're just gonna dive in. Maybe I've already reread this some of this in the previous episode, but we'll just go through it anyway. When a student can effectively apply this technique using a leading stance from either side of the body, they can start applying this technique from a squared off pigeon toe stance. So pigeon toe stance, we explained this yesterday, is if you are standing perfectly, standing normally with your shoulders and your legs shoulder width apart. A pigeon stance is if you lower your body down by bending your knees a little bit and putting your knees together and angling your toes towards the middle a little bit, about 45 degrees in, almost like you're doing. If anybody's done skiing before, if you're trying to do the plow going down the mountain, it's a little bit like that, but your knees are a little bit closer together. That's the closest thing that I can help you guys with here to understand what the pigeon toe stance is about. And launch. Okay, so then from pigeon toe stance and launch into a fully extended bow and arrow stance from that position. The arrow step punch has similar kinesthetics to a football tackle, and it is executed like its name. A punch is shot out non-telegraphically like an arrow head on. So it should be launched in a straight line and can be initiated from either left or right fist. So one of the important exercises is to be able to do that. It is pretty difficult already to be in a pigeon toe stance, but once you can master the pigeon toe stance, from there you should be able to shoot out an arrow step from either direction, either the right front fist or the left. You should be able to launch out this punch and then return to the original pigeon toe stance. If you can't do that, then that will definitely reduce your chances of doing correctly. And then if you fall off balance, then that will be funny, but not so funny if you're trying to use this in combat. Anyway, so the big advancing step shows that this is a long range punch, while the leading stance enables us to fully extend our reach to engage with our target. At the same time, aligning the lead hand, vertical fist, and elbow in a straight line allows us to minimize our opening. One can then maximize the areas of the body that it can be used to resist and the rebound upon impact, which ensures that all of the energy from the punch is unleashed into the target. Just like when you shoot a gun, when you punch something, there's going to be some recoil action. Every action creates an opposite, whatever, reaction and all that good stuff. So just be warned, be warned. The idea is when you push off from whichever leg is the rear leg, and you do that arrow punch, you're creating a tremendous amount of force going forward, just like you would when you shoot a gun. And then, you know, that there's a part of the gun, if the mechanical ones especially, which will recoil in your hand, those modern guns like the Colt Double Eagle, the Smith and Wesson, and a bunch of the modern ones, not the revolver types. But anyway, even the revolver types will have when you shoot, if you don't hold it, they will do that. But it's even more present, and what is more realistic in the Wing Chun is not the old-fashioned, the revolver, the cowboy guns, if you will. It is the modern kind of gun, because human body is made up of a lot of water. There's blood, there's liquids and stuff inside you. So when you shot out that punch, there's going to be recoil action inside you. So make sure to brace for impact, because not only when you hit the target and also when you step back and all that stuff, there will be that shakeage, just like you will when you're holding one of those guns. You shoot, and that thing will go on the top. Anyway, I'm sure you guys know exactly what I'm talking about. And if you don't, get yourself a gun permit or go shoot at a shooting range under the supervision of professionals, or you just watch somebody who does it. There's plenty of YouTube videos where you'll see that. You'll see the top of the gun will do that. Anywho, BB guns probably pretty easy to get today, and so you could get one of those. Furthermore, the power to produce a non-telegraphic and fast punch from a short distance comes from quickly snapping the body, springing into a straight structural alignment, beginning from the toes of the rear foot, and stomping forward with the frontal foot. These movements produce 3 different forces at the same time. So, I guess there's different ways of doing the arrow step. But the better way, based on what is here, is to have a sort of flexed toe in the back. Most of your weight will be on the rear toe, from which you will then push off into the forward arrow step. Now, remember, you could also do the arrow step pushing off the heel, but if you do that, then there's a good chance that your rear leg will slide and slip, and although that may be more stable in some cases, especially if you're caught off guard and you may be falling over, you may have to shoot that arrow step from a flat foot in the back, but the amount of power that you will generate will be less. So just pointing that out for anybody who, and again, if you don't have a very grippy shoe, the rear leg could slide. It's easier to shoot out one of these punches from the toe. You know, like your whole weight is on the toe and your ankle is a little bit bent and stuff. That's going to be easier to shoot out that and create the most power and not slip from the rear leg. So anyway, it's one of those little nuances. That it took me close to 8 years to figure out. But that a natural born athlete would pick up pretty quickly. They just get it, right? They just get it. So students should train every joint in their bodies to develop the necessary flexibility and strength to handle the rebound power and tremendous impact that is generated from executing the punch. Again, be careful when you're doing this punch against stiff objects. If you're going to do it in sparring with a friend and they're wearing their protective gear and stuff, you smack them. Good chance that they will absorb a certain amount of power by moving back, or stepping back, or just by being, you've got the whole upper torso that will naturally move back when hit. So, but if you hit something that is rigid like a cement wall, good luck. If you haven't done the training for the iron training and stuff, you may get really hurt. So, this is especially true for the wrist and knuckles, right? The wrist and knuckles will take a lot of the brunt force, and they could bend, break, tear apart, and all that good stuff. So if you don't want to go to a doctor, just do it with care. You may want to do a lot of these at, 10% of power for a long time until you can really master the technique, and then move on to, like 25%, 50%, 75%. And then if you are really masterful, you could do it 100%, but most people won't even go there, because let's face it, even if you are a master, when you do 100%, there's a good chance you could still break something, especially in your older years. So it is not recommended to go 100%. But the powerful knockout strength of the punch comes from 1, the stomping, which puts the weight of the whole body behind the punch, and 2, the spinning of the body's torso, which occurs as you twist the hip. The sudden straightening of the bone structure alignment then fully transfers the penetrating power. The next step is reflex training. Okay, so this was just all about that famous punch. What do they call it? The arrow step punch. The arrow step punch. Okay, cool. So the next step is going to be reflex training. So the number one bit that they want you to learn here at the Grandmaster Tom Wong Institute, because you can take classes with him in person in Monterey Park. So anyway, so the air step. We talked about air steps, so now we're going to go into the next step is reflex training. Once the student has gone through individual practice in the air, the student practices the punch with a partner or moving target. The student must try to hit the moving target, but not sacrifice power to do so. Afterwards, the student can finally attempt the first score target test. So you will do this, you will be training this practice in class with a nice student. And Grandmaster Tom Wong will make sure that you are paired up with a nice student so you don't get hurt. And you will also, of course, will have to sign a liability thing because, you know, you might be the not so nice student going into class. So he needs to make sure. The students that you will find at his class are all nice students. But if a new student comes in and is not nice, then he needs to have waivers for that in order to make sure that all goes well. So it says to pass this test, the student must have a certain accuracy percentage. This is the reason why some of our students who cannot even do a regular push-up were able to produce a surprising knockout punches in sparring and competition. So basically this shows you that if you can master this technique, you're able to create a lot of power, even if you are quite feeble of power in your normal life. If you struggle with sit-ups and push-ups and all that stuff, if you have those cute noodly arms, you might still be able to create a decent amount of power through technique. And that's the point of this. So the first level students focus mainly on body mass utilization for long range distances, strikes, and training eye and hand coordination. So that's very important to focus on body mass utilization for long range distance strikes and training eye and hand coordination. A lot of times, one of the problems with doing the training wrong and stuff, whatever discipline you may be used to, is that most of your jabs or whatever are short range. So a lot of the time, if you're fighting somebody who is taller and stronger than you, they have limbs that tend to be taller and stronger than you, which means that it's hard to get in contact with their body. So one of the things that you want to avoid is to try to chase their chin if they're a giraffe, right? Good luck hitting that chin. So at the second level at the second level, students should be able to do all of the above at will and without much conscious effort. So that's where the motion training and stuff, training all these things into your body, there's a brain that thinks, and then there's a brain that automatically does, which allows a lot of things to happen automatically in our body, like breathing and all that good stuff. So we're trying to train that other brain, not just the brain that does things consciously, the other brain, to learn a lot of these things. Because when you do that, then the thinking process is less, and so that other part of the brain can take over when we are under pressure. Because, if you're fighting or you're sparring, you're under pressure. And under pressure, you want to do the less amount of thinking. And, there's still strategy to it, of course. But you have split-second decisions to make. And you want the other part of the brain to be taken over so that you can actually react fast enough to the punches that come. And those punches, let me tell you, are very fast. Got distracted by another cute lady and her doggy. what are you gonna do? So anyway, back to kinesthetics here from punching and stuff. So there we go. As I said before, let's drill this because this is important. I'm going to read it one more time. At the second level, students should be able to do all of the above at will and without much conscious effort. Only then will students have obtained initial mastery of the arrow step punch. Afterwards, the student can begin practicing the punch on light targets. Once they have become proficient, they can practice the punch on the heavy bag. Because if you hit the heavy bag and you do it wrong, your wrists, your knuckles, and all a bunch of other things may start twisting, bending, and potentially breaking, which is not worth it. So don't just start your students right on the heavy bag. Screenshot from video. At 65 years old, the author, first person from left, sparred individually with all the second level students. Afterwards, everyone became more humble and set new goals. So it's imperative or important to know that you will not be sparring with Master Tom Wong until you get to the advanced classes. Why? Because it's important to, have goals. You have to have goals. You have to get down to business and really work hard on all of your things, all of your, become masterful in your techniques, and then progress to the second level class. You will have to do a grueling test in order to pass that. So that's how Master Tom Wong weeds out the weak, which is a good method to do it. Here we go. So it says, in addition, students should condition every joint in their bodies to develop the necessary flexibility and strength to handle the enormous impact from the rebound generated from their arrow step punch. The beginning arrow step form and Silim Tao form contain supportive exercises for our joints. Later, the joints are further enhanced through various equipment and weapons training. So it is important to use the arrow step form as well as Silim Tao, as well as external training. So no matter what you do, whether it's ballet, soccer, or whatever other activity, stretching is such a lead and important part of every single thing that you do, even if it's tennis. So make sure you stretch out your joints, make sure you warm up your bodies before you do stuff, because especially as you get older, it is so easy to rip out a joint, rip out a ligament. There's so many things that you could do wrong. And so whenever you're doing things with your body, you want to have a good habit of stretching those things out. Make sure that you are very flexible. Anyway, there is such thing as being too flexible when your joints start popping out of sockets and stuff like that. So you also have to be careful of that. If you are over bendy, especially if you're double jointed, then you have to work hard on strengthening the muscles that keep your joints from pushing beyond the joint. Now, in some cases, like myself, my elbow does not go further than the joint, but I've seen a lot of people who can go beyond the joint, so beyond the straight, and they go further out. And the more further out you can go with your joints, the more likely you could, distort or do something terrible to yourself. So you have to be careful with that. So in some cases, over flexible is bad. There's always going to be that balance. There's always going to be that balance in life where a certain amount of flexibility is good, and over flexing to the next amount is going to be bad. But just generally speaking, if you can do a full split and go to that, I'm not sure if it's called 180 degrees, that is always good no matter what. So that is good to know. If it's one of the goals in life that I have, which I haven't achieved it yet, but I've gotten pretty close, and hopefully I'll get back into that soon. So at level 3, students focus on increasing the punch's proficiency through a combination of equipment training and training with live opponents. The equipment training enhances one's earlier preparations by increasing the intensity of the training. At the same time, interaction with live opponents enables students to improve their reflexes as they respond to the ever-changing interaction between them and their opponents. During interactions with live opponents, students create opportunities for a finishing counter-strike by leading their opponent to where the students want their opponent's limbs to be, in one, an open form, or two, close quarter attack by applying sticky hands, and or sensing and spontaneously following the opponent's unpredictable responses. This allows students to train simultaneous defense and counter strikes and get comfortable fighting at medium range. Excuse me. All right. So it's important to train both long range and short range because you never know what kind of opponent you're going to find in the real world. Some people are very good at long range. Your Taekwondo people tend to like to keep you at pretty far range. Then they'll move in fast and throw a few kicks and punches, and then they'll move out. As opposed to jiu-jitsu people, which will come really, really close and try to grab your arm and leg or whatever and pretzelize you or whatever. So you got to have a good understanding of both ranges in order to counteract or counter the different disciplines. So that is what Grandmaster Tam Wong is doing there to make sure that the students are prepared. It is only through such live interaction that students can effectively practice sticky hands, as well as learn how to apply combination counterattacks. This is because a heavy bag is dead, right? Everybody talks about this over and over and over. I'm not sure if Bruce Lee said it at some point, but it became famous at some point by somebody saying that punching bags don't punch back. You know, trees are not going to hit back unless you break a tree and it falls on your head. It's not going to hit you in general. So while humans are living and ever-changing, they keep moving around and doing stuff like that. Inanimate objects do not. So, I mean, with the heavy bag, yes, it will go forward and then it will come back and hit you. But that is limited. That is not a very shaky, wobbly thing. If you ever try to hit somebody who's good at dodging, ever try to hit somebody's head when they're good at doing all the dodgy stuff with their head, it is not easy to hit somebody's head. So anyway, so this type of sparring that involves the application of sticky hands techniques is an example of the principle of Taoism in action. Additionally, grappling and anti-grappling in conjunction with striking are introduced. At level 4, students focus on even wider spectrum of variable responses and efficiency training. Okay, so at this level, students must be able to use the sticky hands skill to flow with their opponent's random attacks energy, seek openings, and follow up with combination wooden dummy counter techniques once they find these openings. So a lot of these techniques, the students will be practicing on end with gloves on, which is very, very difficult because everybody explains, or I've explained as well in previous videos, once you put gloves on, it is hard to hold on to your opponent. So although some gloves give some kind of ability to hold on to your opponent, most of the sticking that will be happening will be glove to glove. And so it's going to be also with gloves on, it's hard to bend your wrist. And a lot of the Wing Chun relies heavily on you being able to bend your wrist. If you go through the Siulin Tao forum, it'll show you all kinds of ranges, which is why it helps create flexibility in your joints, whether it's your wrist joint, your elbow joint, and stuff, in order for you to be able to do all of these crazy maneuvers and stick onto your opponent without necessarily grabbing, but using different parts of your hand to just stick, similarly to how a snake is able to hold on with its snake body onto your arm. It does not have hands, it does not have fingers, but it uses parts of its body to sort of slide and create pressure and counteract different forces and interact with your arm. It's very difficult to explain. You will have to go take classes with Grandmaster Tom Wong in order to understand these principles. It's not something that can be explained through Zoom or live streams like this. Anyway, so meanwhile, all the fundamental supporting conditioning, including the Qigong exercises, should have advanced to new heights. Some additional supplemental hand conditioning, stretching, and weight training are also done at levels 3 and 4. So there is a certain amount of weight training. Again, with weight training, kids, please be careful. If you're going to learn the proper techniques, learn the proper techniques, do the proper techniques by using the forces in your legs and lifting correctly and stuff. I had to have an inguinal hernia done when I was young because I was crazy the way that I lifted objects of all kinds and overexerted myself. I would lift people who were way, way heavier than me, like an ant-man, and it was a bad idea, and it caused me some serious injury, which now I have to live with a mesh inside the inguinal area, which is never a good thing. And over time, it still hurts, or it causes pressure, so it pushes the other inguinal hernia on the other side to come out. So at some point, I'm hoping never, I might have to do another surgery to put a mesh on the other side, which is not something that you want to deal with. So be careful whenever lifting weights. Do it correctly. Have a professional teach you how to do it. Don't just go out and do stuff. And please don't lift people who are heavier than you. It is not a great thing to do, especially if done awkwardly and wrong. It will cause serious detriment to your lifestyle. So anyway, at these levels, we learn to hack away the non-essential, but cutting down the time needed to counterattacks while becoming more efficient with applying our techniques. By refining one's response and utilizing unpredictable attacking energy, one can punch or make a punch appear visually strong, but land the punch lightly. So that's a famous feint, right? That's a famous feint that a lot of boxers will do, and this is why traditional American boxing, or Western style boxing, looks a lot like Wing Chun. It has slightly different principles, but it does look a lot like Wing Chun. And that's also why a lot of people coming from boxing find Wing Chun to be a lot easier to learn than people coming from hard style, whether it is, hard style from the monks region, or hard style from karate or taekwondo and stuff, because you learn a lot of bad habits. I'm not saying the techniques are bad or anything, but they're bad habits that make it hard for you to learn how to do Wing Chun, or at least this particular branch, like from the tree branch of the Aomei Wing Chun. It is harder to learn this one if you have hard style karate bad habits. So at the same time, one can make a punch appear light, but deliver a heavy blow. This technique can be quite disorienting for people who are accustomed to judging everything based on appearances. For example, many people debate about the hard style versus the soft style, but have zero understanding of the differences between the two philosophies, besides what they have learned from their own limited observations. So one thing that you will learn in this book, but also if you go and do the proper training, is that there is some tensing when you do sticky hands. The whole point of the technique isn't just to be completely like a zombie, like, they can just wave around, stuff like that. It's not just wavy. There is some resistance that is created within the sticky hands, and if you don't do any of that resistance, the opponent can just move or get out of your lock, and you won't be able to stick to their arms. So there's a lot of stuff that goes on in there, and also there is a lot of interesting techniques that can be applied through sticky hands, such as your opponent may be punching and coming at you, and you are just maybe laying your arm on top of their arm while they're jabbing at you, and they don't even realize that you're there. until they jab, and then they realize their punches are not reaching through your defenses, which is a very, very high level, like top level technique that most kids won't even learn like until maybe they've done like 8 or 9 years into the technique, and some people can't even apply it. May need to come back, reincarnate themselves, and do this whole living experience maybe 3 or 4 times before they can actually understand how it works properly. Anyway, so some of the stuff is just way brainiac, and I've only been able to see some of this stuff when sparring with my friend Charles, and it is crazy. It is crazy because like it's almost comical. There's a couple of videos I think on this YouTube channel when you'll see me sparring with my friend Charles. I'm going at 100 miles an hour. I'm shooting arm techniques, and not even noticing at some points that his arm is actually on top of one of my fists. I'm not even realizing that it's there, and then all of a sudden I'm getting hit by that arm that I wasn't even aware was there. So that's it's very, very interesting stuff. Anyway, finally, a student must test and apply the arrow step punch with different partners. Sparring with an unfamiliar partner is always better. Why? Because if you spar enough with one person, eventually you will understand their basic routines and techniques and setups. So eventually you'll be able to, again, using that part of your brain in the back, not the main brain, but the one that's all about the motory actions, such as your lungs moving and your heart pumping and all that stuff. You'll be able to have enough information in there that when somebody strikes, you'll know how they strike, when they strike, their rhythm and all that stuff. So it is very, very difficult to find someone who is almost unpredictable. There are a few people out there that are that amazing, but they are very few. So anyway, so anyway, that is why they want you to keep switching your partners in class, so that does not become so familiar that you get too accustomed with your partner. So then after that, so when our students get too familiar with each other, they need to find training partners from other styles to spar with to continue improving their reaction time against unexpected occurrences. That's why you go and join tournaments. That's why you find a lot of the students will then go to different other gyms to do sparring and stuff like that. Why? Because, you want to keep progressing. You never really want to plateau in your martial arts training. Of course, at some point you will plateau, but you try to make it interesting for yourself as much as you can. This rings especially true for the more advanced students. In addition, it is our school's tradition to encourage our students from different training backgrounds to spar with our other new students to assess their progress. Sorry, I'm going to start this again. I completely misread that. In addition, it is our school's tradition to encourage our students from other different training backgrounds to spar with our new students to assess their progress. So this way they're able to see how good the newest students that are coming into the class are by sparring against their good students in their class. And that's one of the cool things that I got to do, which I got to, I wish I had better stamina and training, because I blew out all of my energy very quickly. So I only got to spar with a few of Grandmaster Tom Wong's students, and that is that is my one regret there, is I wish I'd gotten a chance to spar with more students and possibly go back there someday. Who knows? If time and circumstances will allow, it'd be fun to go back there to spar with the students again. But anyway, yeah, so again, you get to spar with different students, different styles and stuff. And again, based on the different styles, you will find that some people will have very, very soft attacks, and others will have more elusive attacks. There was one guy that I sparred with which had a very evasive kind of attack, and it was like my nemesis. because I could never get one punch in through to this guy. And it's basically when you spar with all the gear on, you have limited ability to see through this, especially if you use the gear that goes and covers your entire face. It's almost like a helmet, and it has a plastic, very powerful plastic thing on the top. But anyway, limited vision. So whenever I spot with him, he would be like a ghost. I couldn't see where he was. I didn't know where his punches were coming from, and so it was very hard to pin him down, to get even one punch through. Yeah, so that's one thing. And then there was another guy, really soft punches. It felt like when I was sparring with him, of course, he was toying with me. He was at a completely different level of capabilities. But I was trying to go in and try to get through his defenses. But it was like being attacked by an army of pillows. Dun, 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 and then eventually I lost the battle. And again, going in as a beginner and learning things, just learning the ropes of how things were. Okay, so the battery on this thing is dead, and this is why it's going to be the end of the live stream. But tomorrow we're going to continue on from page 122 and 123. So that was my little going off there with that. Hope you guys enjoyed this video. Hope you guys are enjoying this book. If you don't have this book, go and get yourself this book. It is on Amazon. And with that, who cares about my spiel about 3D printing anything? I'm not going to do that. I'm just bored of doing that. Nobody cares about that anyway, so I'm just going to keep talking about this and this until we're done reading all about this cool stuff. And I will see you guys all in the next video. Hopefully it'll be tomorrow. And maybe if there's time, I'll be able to do some real flight and stuff. But the battery is dead here, so got to charge that battery before this phone dies all the way. Anyway, thanks for joining me on this adventure, and I will see you all, as I said before, in the next one. Take care, guys. Have a great day.